I have liftoff, clock is started, and she feels real nice.
You pull your gear pins for this flight?
Yeah, I got the pins on my office wall, altimeter's off the peg.
All right, have a go from here.
Roger, it looks real good.
Are you a turtle today?
Going to Vox record only. You bet your sweet ass I am.
This is Mercury Control. The time here at Cape Canaveral is 6:02 a.m. Eastern Standard Time. The countdown for the attempted launch of the Sigma 7 spacecraft on the 5th U.S. manned spaceflight is T-minus 57 minutes and counting. The months and months of current research, development, manufacturing, test, and training which have been conducted in Project Mercury all point toward the time some 57 minutes from now when the Atlas launch vehicle will lift the Sigma 7 spacecraft from the launch pad and accelerate it to an altitude of about 100 miles and to a speed of some 17,540 miles per hour in space. Then, yesterday morning, the pace of preparation became directly related to and was swung into rhythm with the clock, the inevitable ticking off of hours, minutes, and seconds to a pre-planned point in time this morning. Yesterday morning at 5 a.m., a small group of engineers and technicians went out to the launch complex here at Cape Canaveral, where the Atlas Mercury combination stood poised, waiting for the skilled men to check and test each intricate segment of its systems, and then finally to turn the key which would ignite the powerful rocket engines and launch another major step in our national manned spaceflight research effort. Mercury astronaut Walter M. Schirra was awakened this morning at 1:40 a.m. by Dr. Howard K. Minners, our flight surgeon. Schirra had breakfast with the director of NASA's Manned Spacecraft Center, Dr. Robert R. Gilruth, with our associate director and Mercury operations director, Walter C. Williams, with astronaut Deke Slayton, and with Dr. Minners. Breakfast took place in what Schirra calls the astronaut mess. The big white transfer van moved away from Hangar S with Schirra on board at 4:10 a.m. this morning. He stepped out of the transfer van at the launch complex at 4:37, walked directly to the gantry, and rode the elevator up to the 11th deck where the Sigma 7 spacecraft was waiting. The U.S. Weather Bureau observers report the tropical storm Daisy has continued its west-northwesterly movement during the night. The center of the storm now lies between the pre-planned landing areas for the end of orbits 2 and 3. And that location is some 310 nautical miles north of San Juan, Puerto Rico. We have moved recovery ships located at the end of the second orbit approximately 100 miles east-southeast along the track during the night. They are essentially out of the storm area at this time. The aircraft carrier Champlain, which is the prime recovery ship at the end of the third orbit, has sent a report about a half an hour ago indicating that conditions there were excellent. As of this time, all the checks and preparations have proceeded satisfactorily. Astronaut Walter Schirra is in the cockpit of the Sigma 7 spacecraft. He is alert, confident, and cheerful. The Atlas launch vehicle and the recovery forces in the Atlantic and Pacific and the weather conditions are go. We have had one small technical problem during the night and early hours this morning with one of the pieces of radar equipment out at our Canary Island tracking station. However, this problem is not expected to seriously affect the mission or delay the mission. The countdown now here at Cape Canaveral is T-minus 54 minutes and counting. This is Mercury Control.
7.5 hours is a long time.
I agree with you on that.
Sitting, there is some hazard for 7.5 hours, as you know. Did you follow any routine in particular? Did you do as we asked and flex your ankles, move your toes, strain at the calf?
I felt I had to do that. You do feel cramped, as you say.
You become restless.
This is, of course, quite different than our normal attitude. We'll be on our back, almost in a prone position. I notice, though, that it's easier to move your legs, as I am right now, in a seated condition, because you can just swing your legs. But on your back, you have to lift your legs to flex your muscles. Although your advice to flex them is a darn good tip.
Wally, during this simulated mission, divided into parts for responding to the question, consider first liftoff and the orbital parts of the mission. At that point, all you have to do is just maintain comfort control. Were you able to do that?
The coolant valve settings that we were playing with in orbit sure proved a lot to me, because the intercom system was telling me what my suit inlet temperature was and what the suit outlet was, and Looks like I like about 68 to 70 degrees.
Good. Now, the harder part of it, of course, is the reentry phase where the inner skin walls of the capsule approach 290 degrees Fahrenheit. Then with this surface that hot, so close to you, inches away, were you able to perceive this temperature?
Only by radiation. I could feel the heat from the panels coming up on my cheeks through the clear section of the visor plate. And this was a very low order of heat, I'd say, like a nice sunny day out on the beach.
It was entirely comfortable.
Oh, yes. I also noticed on my hands with the black leather surface facing the heat of the capsule wall that the heat would build up on the black. Yet when I had the silver side toward it, it was very, very comfortable, and it only proves that the reflective qualities of the silver surface is really worth having.
Test 66, bring up command carrier. Bring up command carrier, test 66. Test 66, capsule telemetry on, external power, turn on signal strength, center frequency recorders. T-minus 50 minutes and counting, test 66, minus 50 and counting.
Running. Camera running.
Roger. Your correlation clock edge light?
That's firm.
Okay. Your discretion, Henry.
All right.
Pad leader, have you cleared?
The elevator is descending. I assume he's on it.
Roger, let me know when you see him.
Roger.
Camera and tape recorder still running.
Roger, yeah, this is a 60-second check.
Oh, okay.
Okay, gunner's coming down on the second load, Paul.
Roger.
Camera and tape off now.
Your attention please, test 66. We're at T-minus 45 minutes and holding. Minus 45 minutes and holding, test 66. We estimate 15 minutes in the hold. 5 minutes.
This is Mercury Control. The countdown for the launch of the MA-8 now stands at T-minus 45 minutes and holding. We are holding for repairs to that radar equipment out at our Canary Island tracking station. We estimate this hold at this time to last for 15 minutes. The countdown is at T-minus 45 minutes and holding. This is Mercury Control.
Test 66, C and S band beacons are on, external power. Test 66, UHF voice check started, capsule low power transmitter on. Your attention please, test 66, T-minus 45 minutes and holding. We expect to resume the count in 2 minutes. Test 66, we've resumed count, T-minus 45 minutes and counting. Start capsule signal strength center frequency recorders.
This is Mercury Control. The time here at Cape Canaveral is 6:32 a.m. Eastern Standard Time. The countdown for the launch of the MA-8 mission is now at T-minus 42 minutes and counting. We have had a minor technical problem with a radar equipment out at the Canary Islands tracking station this morning, but we do not expect it to affect the mission seriously or delay it particularly. The countdown again here at Cape Canaveral is T-minus 42 minutes and counting. This is Mercury Control.
This is the Mercury spacecraft, designed to sustain a man in orbit and return him safely to Earth. This is the Atlas, the powerful launch vehicle that will place the spacecraft in orbit. These are the men selected to fly in the Mercury spacecraft, the astronauts. Malcolm S. Carpenter, Leroy G. Cooper, Jr., John H. Glenn, Virgil I. Grissom, Walter M. Schirra, Alan B. Shepard, Donald K. Slayton. It has become evident that full utilization of space flight requires man's ability to participate. Human intelligence and decision-making capacities are essential. Project Mercury. Its objective is to ensure safe orbital flight and recovery of a man in order to study man's capabilities in a space environment. These studies will form the basis for man's exploration of space. This is the flight plan for a normal Project Mercury orbital mission. However, if trouble develops on the pad, or early in the launch while the vehicle is still in the atmosphere, the escape rockets on the tower fire and thus propel the spacecraft away from the vehicle. Then a parachute system lowers the craft to the ground. In a normal mission, the vehicle is launched and proceeds to staging or release of the first stage vehicle engines. 15 seconds later, the escape tower is jettisoned, further reducing vehicle weight. Escape is now provided by cutoff of the vehicle sustainer engine and the normal separation system. Once the proper altitude, velocity, and angle for orbit have been achieved, the guidance system initiates engine cutoff, and the craft is separated from the launch vehicle by 3 posigrade rockets. 5 seconds later, the automatic control system turns the spacecraft around through 180 degrees and pitches it up about 35 degrees, the correct attitude for firing retro rockets in case an emergency develops. The attitude control system stabilizes the craft. 100 miles above the Earth, the craft travels 18,000 miles per hour. After 3 complete orbits around the Earth, the craft is returned to the retro-firing attitude, and the retro rockets fire. This slows the craft, allowing the Earth's gravity to pull the spacecraft out of orbit. The control system maneuvers the craft to its re-entry attitude, and the retro package is jettisoned. During re-entry, aerodynamic heating causes the heat shield to glow. 4 to 8 miles above the Earth, a drogue parachute is deployed to help stabilize the craft and slow the rate of descent. At 10,000 feet, the main parachute is deployed. A few minutes later, the spacecraft lands in the ocean. The parachute is released, and recovery aids such as dye markers and radio signals guide recovery teams to the area. Early in 1959, only 3.5 months after program initiation, design concepts for the project were firmed up, and a production contract was assigned to the McDonnell Aircraft Corporation. 2 months later, an engineering mock-up was inspected and accepted. Well over 100 wind tunnel tests were conducted on 70 models of Mercury configurations. Models ranging in size from 1% of full scale to full scale. One of the first projects was the development and testing of a heat shield to protect the spacecraft from the terrific heat encountered when entering the atmosphere. The afterbody has a double wall separated by large amounts of insulating material. Here, outer wall shingles are tested to destruction in a high-temperature supersonic wind tunnel. These are the posigrade rockets that separate the spacecraft from the launch vehicle. Component testing simulates actual conditions as closely as possible. Here, a complete Mercury spacecraft autopilot and attitude control system is tested. The table is tipped. The autopilot senses this and commands the reaction jets to return the table to the correct attitude. Escape rockets are tested. Detailed analysis shows that these rockets will pull the spacecraft clear of the launch vehicle at least a fraction of a second before a catastrophic failure on the pad or before vehicle staging. The blast from the nozzles is directed out and away from the top of the spacecraft. To take up the initial landing impact on either land or water, an air cushion was developed for the spacecraft. There's constant emphasis on reducing the risk involved in orbital flight. Every essential system is duplicated at least once to provide a backup in case one fails. As test results become known, modifications are made on the engineering mock-up. Every possible check is made to ensure that production hardware maintains the original design quality. Astronaut selection criteria have been specific. Test pilots with over 1,500 hours flying experience, past performance and engineering capabilities outstanding. The qualities always necessary in any flight research program. An academic program thoroughly informed the pilots on astronautics, space mechanics, and other aspects of space flight. The astronauts have made a great many contributions to improve the effectiveness of Project Mercury. They work closely with the engineers. Each man is assigned to a particular phase of the program, such as communications, tracking, or the launch vehicle. He keeps his fellow astronauts informed on any changes or modifications. Zero-gravity flights in aircraft prepare the astronaut for the condition of weightlessness they will encounter in orbital flight. The schedule also provides for continued proficiency in high-performance aircraft. The technical requirements and the physical and mental stresses involved in Project Mercury are similar to those confronting an experimental test pilot. The astronauts learn to tolerate the heating that may occur in case of ventilation system failure during spacecraft re-entry into the Earth's atmosphere. Every effort is made to ensure that the astronaut will be familiar with the conditions he may encounter in flight. Training for the astronauts is rigorous and comprehensive. Object: anticipate every possible flight situation. Simulate the problem realistically. Train the men to meet the situation almost automatically. One of the most important phases of the training program is readying the astronauts for the high acceleration and deceleration forces of launch and re-entry, the crushing G-loads of an emergency escape. This centrifuge produces the same forces on the same time scale as the forces the pilot may encounter in flight. The program indicates that all stresses anticipated in flight are well within the tolerance limits of the astronauts. In this simulator, the astronauts practice controlling craft attitude by manual control of pitch, roll, and yaw jets. The problem is to control the spacecraft about 3 axes with a hand control that functions best in 1 axis at a time. It takes practice and practice and practice. And then, on to a more difficult simulator for more and more experience. The entire Mercury mission can and will be run initially without a pilot. System duplication and automatic sequencing provide all necessary functions. However, a pilot in the spacecraft with manual backup controls for all primary functions greatly increases the overall system reliability. The time available to perform a task manually if automatic system failure occurs is small. The skill required for many of the manual controls is great. A thoroughly trained reflex condition pilot is the only answer. On water impact, the pilot will normally sit back and wait to be picked up by helicopter or ship. However, in an emergency, if the craft is sinking or ventilation fouled, the pilot can climb out through the top. Or, for emergency speed, blow off the side hatch. This method may be used successfully even after the craft is sunk beneath the surface. The astronauts receive extensive training in sea and land survival techniques. There's always the slight chance the spacecraft may land outside the designated area. The pilot is prepared and equipped to survive while waiting for the recovery teams to reach him. Training covers every conceivable eventuality, every emergency, no matter how unlikely it is to occur. The spacecraft procedures trainer is an exact duplication of an actual flight craft. Every control and instrument functions. The trainer enables the astronaut to fly mission after mission, become completely familiar with the location and operation of every control and instrument. He learns to handle emergencies as fast as the instructor introduces them electronically. To make training more realistic, the noise background of powered flight is inserted. The pilot experiences the physical discomforts of the temperature and pressure-regulated suit, and time in the trainer is prolonged to produce fatigue. Dual microphones feeding into 3 radio systems give the pilot constant voice communication with the tracking stations as the spacecraft passes over. Oxygen, pressurization, and ventilation in both the cabin and the suit are adequate for a minimum of 28 hours. Once separated from the launch vehicle, manual backup controls provide the astronaut with the capability of controlling the craft throughout orbit, retrofiring, and recovery. In addition to reliable hardware and trained pilots, Project Mercury requires a worldwide network of tracking and control stations, manned by men thoroughly trained to do their jobs, too.
Test 66, T-minus 30 minutes and counting.
Have your attention, please. The radar condition at Canary Islands was reported to be green at 6:38 a.m.
The Mercury tracking range consists of 16 stations, some already in existence, others under construction. The orbit path is planned to keep the spacecraft in the Earth's temperate zones and to take maximum advantage of existing tracking stations in the re-entry and recovery areas. Planning and construction of the stations around the world proved to be a major segment of Project Mercury. The tracking stations will monitor spacecraft flight at all times, stay in continuous contact through telemetry or voice communications, exercise operational control over the mission. The training requirements for tracking station personnel are extensive due to their large numbers, their distribution all around the globe, and the need for them to operate as one worldwide network. The Project Mercury Control Center at Cape Canaveral is the nerve center for flight missions. In the training operation, trajectory data, spacecraft systems information, emergencies, all data encountered in actual flight are introduced to the monitoring consoles. Orbit predictions must be available at the instant of launch vehicle burnout, not hours or even minutes later. A complete network of communication is simulated between a spacecraft and between tracking stations. In effect, complete missions are flown again and again. The control center determines from all available data the progress of the mission. If an in-flight emergency arises, the flight can be terminated. Every effort is made to land the spacecraft in a desirable recovery area. The track board constantly indicates the position of the spacecraft and its probable landing point should emergency re-entry be initiated. In this way, recovery forces can be on the way to the landing area immediately. The next job, direct the search and recovery activities. Flight testing began early in the program to verify design concepts and check out prototype systems. Free-fall drop tests were conducted with full-scale spacecraft models. The pyramid of testing had begun. Test a component, then a subsystem, then a system. Put several systems together and test the overall capability. Keep testing until complete unmanned orbital missions have been flown. Then you're ready. September 9th, 1959, less than 1 year from program inception, a prototype spacecraft was flight tested on an Atlas launch vehicle. It was not equipped with an escape tower since the escape system was not being tested. The objective was to match the ballistic trajectory of the craft to the re-entry path of a spacecraft coming out of orbit. The craft would then encounter the same heating environment. During this test, the spacecraft re-entered the atmosphere in a steeper angle than planned, producing higher temperatures than expected. The craft took this excessive heating extremely well. In fact, the test produced more constructive data than if it had progressed as planned. This is the nature of a space-age flight test program. At 2:19 a.m., to provide maximum daylight for search and recovery, the first Mercury rocket-boosted flight test vehicle was launched. Search and recovery teams worked smoothly. Even though the spacecraft landed outside the anticipated landing area, it was located and recovered in just under 8 hours. When orbital missions are flown, aircraft search teams and ship spacing provides normal recovery in less than 3 hours.
T-minus 25 minutes and counting. T-minus 25.
Test 66, booster telemetry and Azusa are on, external power. Test 66, stand by for range safety command checks.
Early in the program, a new solid propellant launch vehicle was designed, developed, and fabricated for research and development flight tests. Called Little Joe, the vehicle was used primarily to test the escape and recovery systems for the spacecraft. The first Little Joe was launched October 4th, 1959 at Wallops Island, Virginia. The test successfully demonstrated Little Joe's capabilities. November 4th, 1959. This test checked out the Mercury spacecraft escape system under the most severe conditions anticipated for a mission abort during launch. The parachute landing system operated properly, the craft was retrieved, and post-flight examination furnished the desired information. Here are the parachutes just as the astronaut will see them through his periscope. December 4th, 1959. This test simulated a high-altitude abort. Carrying a small rhesus monkey, abort was initiated at 96,000 feet, while the vehicle was traveling 5.5 times the speed of sound. During flight, the monkey was subjected to about 3 minutes of weightlessness with no ill effects. In spite of heavy seas, the craft was recovered within 2 hours after launch. All test objectives were met. January 21st, 1960. In a test of the emergency abort system under maximum airload conditions, Little Joe number 4 also carried a rhesus monkey. The flight lasted 8.5 minutes with a successful landing 10 miles offshore. The craft was picked up 4.5 minutes later by one of the Recovery Force helicopters. The research and development flight tests provide continuing training for the recovery forces in addition to verifying design concepts. Atlas launch vehicles for Project Mercury are assembled in San Diego at the Convair division of the General Dynamics Corporation. These are the launch vehicles to be used to accomplish the ultimate Mercury mission: put a manned spacecraft in orbit and return it safely. Everything possible is done to minimize the risk involved. Every part scheduled for a Mercury booster is marked or tagged with a Mercury label. 100% inspection of all parts assures the highest possible quality. System testing is exhaustive. At the Marshall Space Flight Center, Redstone vehicles undergo the same exhaustive tests and inspections after being received from Chrysler's production plant. These launch vehicles flight test production hardware.
T-minus 20 minutes and counting to 66, minus 20 and counting.
At McDonnell Aircraft in St. Louis, production spacecraft are ready. Prototype development and research and development tests have been completed. These spacecraft will ride a Redstone or an Atlas, eventually carry a man into orbit. Final assembly takes place in a super clean white room. Here too, every test and inspection possible is made to ensure reliable operation. Only 16 months after contract initiation, the first flight test of a production spacecraft involving an off-the-pad abort was entirely successful. After launch, the spacecraft escape tower combination makes a stable climb to more than 2,000 feet. At the peak of the flight, the escape tower separates, falling well clear of the spacecraft. Slow-motion photography shows the complete sequence in easy-to-follow detail. The drogue chute slows and stabilizes the craft, maintains the proper attitude for main chute deployment. The antenna canister is jettisoned, automatically deploying the main chute. No man-conceived project can guarantee 100% reliability. Yet, Project Mercury must come as close as is humanly possible. Since Project Mercury is a manned flight, the pilot must have an escape capability during the powered portion of his flight. This emergency escape system gives him that capability. The main parachute is intentionally reefed for a few seconds to reduce the opening shock, then opens to its full area. A 63-foot main chute brings the craft to an approximate 20-mile-an-hour landing, the impact cushion taking up the initial shock. The main chute is released to avoid dragging the craft, and the emergency chute is jettisoned. Within minutes after landing, a helicopter from the Mercury Recovery Forces picked up the spacecraft. In November 1960, the first Redstone-boosted Mercury spacecraft was scheduled for launch. Just 2 years from program inception, production hardware was ready to fly, the result of parallel production, research, development, and training. The Redstone launch vehicle qualifies the actual hardware, the production spacecraft, the actual systems in space. In addition, the Mercury Redstone will provide training flights for the astronauts. Of course, animals and instruments will make the first flights. The vehicle will not place a spacecraft in orbit. It will boost the craft through a ballistic trajectory for recovery on the Atlantic test range. On this mission, launch was not accomplished due to premature booster engine shutoff. The spacecraft received a signal saying it was 40 miles up in space, so it began to do exactly what it was supposed to do. First, the escape rocket was jettisoned. The parachute recovery system then functioned exactly as it would on a normal flight. A month later, the same Mercury spacecraft was launched successfully and recovered. This is a Mercury-Atlas system being assembled for flight. A complete mechanical and electrical checkout follows. After static firing, the spacecraft receives a final operational check. A review board then decides whether the mission can proceed on schedule. On July 29, 1960, the first Atlas-boosted flight of a production Mercury spacecraft was attempted. This research and development effort ended after 60 seconds of flight with an unexplained breakup of the vehicle. Manned orbital flight will require more research and many more flights. On the next Mercury-Atlas flight, static firing gave notice of launch readiness. Project Mercury. The program is complex and worldwide. A successful mission, orbit a man around the Earth and bring him back safely, will be the result of a team effort. A team that involves, in addition to the National Aeronautics and Space Administration, the facilities and personnel of all the military services, United States industry, and research institutions. When the craft has been qualified in space flight, when astronauts have ridden ballistic trajectories, when everything is ready, the manned orbital mission will be flown. When this happens, a pilot will sit in a capsule like this one, on a launch vehicle like this, and start his journey into space. Through his periscope, he will watch the Earth recede, as in this Little Joe photography. In orbit, he will see the Earth far below. And then, he will come back to Earth safely. Project Mercury, the proving ground for man's flight into space.
Test 66 on my marks and manual fuel cutoff. 3, 2, 1, mark. Take it away, please. Test 66, switch to high power command transmitter. High power command, test 66. Test 66 on my mark, FIDO, send ASCO. 3, 2, 1, mark. Test 66 on my mark, Burrows, send ASCO. 3, 2, 1, mark. Take it away, please. Test 66, switch to low power command transmitter number 1. Low power number 1.
This is Mercury Control. The time is 7:10 a.m. Eastern Standard Time. The countdown for the MA-8 launch is now at T-minus 5 minutes and counting. T-minus 5 minutes and counting. All elements of the MA-8 mission at this time are in a go condition. This is Mercury Control.
Verify tape recorder running.
Tape recorder is running. Liftoff light is on.
Vox fire to transmit record.
Roger. Vox transmit record.
45 seconds.
Arm switch to arm, engine prep complete.
Minus 1 minute 40 seconds.
Missile to internal power.
Okay, I'm getting the count.
Roger.
Minus 1 minute 30 seconds.
Let's see how...
25 seconds. 1 minute 20 seconds. Our system's ready. 1 minute 15 seconds.
Status check, missile power. Go. RF systems. Go. Propulsion. Go. AMR telemetry. Go. Telemetering quality. Go. Mercury spacecraft.
Mercury is go. T-minus 60 seconds and counting.
Autopilot arm switch to arm.
Water to full flow.
Minus 55.
Ready light on.
Ready light on.
Minus 45. Minus 40.
Status check, pressurization. Go. LOX tanking.
Minus 35.
Water systems.
Go.
My scope is still out.
Mercury
Okay,
spacecraft.
umbilical disconnect. Scope is coming
All
in.
pre-start panel lights are correct. Ready light
Roger,
on.
scope light out.
The scope retract.
Roger, Dick. How about a count?
Tank signal.
Okay.
Gain.
have liftoff. Clock is started. And she feels real nice.
You pull your gear pins for this flight?
Yeah, I got the pins on my office wall. Altimeter's off the peg.
Stand by for 20 seconds.
Okay.
2, 1, mark.
Roger, backup started and running good. I'll give you a hack at my 30. Oh, she's riding beautiful, Dick.
Looks real fine from here.
Mark, 30. Okay, fuel is okay. Oxygen okay. All systems appear to go, and she's getting noisy. Not at all too noisy. Easy to talk through. Okay, cabin pressures relieving on schedule. Fuel is okay. Oxygen is okay. Cabin pressure 10 psi. And she's really moving. Okay, Capcom, Sigma 7, do you read? Over. Cape Capcom, this is Sigma 7. How do you read? Over. Cape Capcom, Sigma 7. I read you. Over. Cape Capcom, Sigma 7. I read broadcasting in the blind. G is building. All systems are go here.
How do you read now, Wally?
I read you beautiful.
Okay, you had your transmitter key. That's why we couldn't read.
I'll be darned. I'm pushed to talk now.
Stand by for staging.
Okay. I have a beaco. Oh, I can see the flash.
Staging.
Roger, staging. Standing by for tower. Fuel looks good. Oxygen looks good.
Right, sounding real fine.
Okay, I'm on push to talk, and the sun's coming in the window now. Okay, there goes the tower.
Roger.
Order retroject off. That tower really is a sayonara.
Right, spit should be about -10.
Roger, that's about -5. Cabin pressure's holding very well at right at 6 psi.
Roger.
And I'll give you an electrical check now.
Okay.
Okay, AC and DC are all in the green. Looks real good.
Roger.
I'll go back on Vox again. How do you read me on Vox now? Cape Capcom, Sigma 7.
7.
Okay, I'm back on push to talk.
Right, we have a go from control center.
Roger, you have a go from me. It's real fat.
Right, we have a go from here.
Roger, it looks real good.
Are you a turtle today?
Going to Vox record only. You bet your sweet ass I am.
Good time to catch you on that one.
Okay, I finished Vox record. Coming up on 4 minutes, I'll give you a hack.
Good head.
Mark.
Right, right on the nose. Repitch.
Okay, and I've got good fuel, about 101.95. Oxygen is fat, 65.52. Correction, 72.
Okay.
She's starting to build up now.
Right.
Sunlight's in my upper right-hand corner of the window, just peeking in at me.
Roger.
How's the view over VR?
I get 0.8 V over VR.
Good, Joe.
Stand by for Chico. Seco.
I have Seco, caps up, and then locks down, and it's very pleasant. Going to fly by wire low, going to fly by wire.
That's fly by wire.
Yaw is answering very nicely. Roll answers nicely. She's turning around very nicely.
Got a call with tomahawk capability.
Very good, I like that kind. I can see little ice crystals. I'm sure that's what it is around me here.
You're a little garbled.
Okay, got a good view of the Earth now. Coming around to retro attitude. Coming into retro attitude, and the good shot of the sustainer here. He's right in the window where it belongs, so I'm pitched up a little bit.
Roger.
Okay, I'm just about in retro attitude.
Roger, we have port communications. Staging, you confirm retrojet off?
That's affirmed. My retrojet was off.
Okay, fine.
Okay, I'm getting set up for yaw. I can see yaw at 34 already.
You do have good yaw?
Roger, I just went into ASCS at about 7 minutes and 10 seconds. The sustainer is sitting very steady above me, I should say above the horizon. And I'm in chimp mode right now, and she's flying beautifully.
I'll give you one of the retro, 1622.
Roger, understand 1622, is that correct?
1622.
Okay, I've got my chart case out, I'll put that in. I'll send the blood pressure now for the medics.
Roger.
Oh, that sustainer looks real cute. I'll pick her up in a while and track her.
Your information, you are slightly garbled.
Okay, I'll use Vox to push to talk as much as possible.
Yeah.
Okay, I'm stopping that blood pressure run. Well, this ASCX is tracking very nice. Sustainer is very stable. It is not oscillating at all. I see no vapors. It looks very clean.
2825.
Say again, Deke. Cape Capcom Sigma 7. Say again.
7 Capcom is fading. You are fading.
Roger. Cape Capcom, I read you loud and clear.
Sigma 7, Cape Capcom, how do you read?
Cape Capcom, this is Sigma 7. I read you loud and clear. How many? Cape Capcom, Sigma 7, how do you read? Over. This is Sigma 7, squib off. Three retrofuse switches on, fire arm armed. Going to fly-by-wire low. Sigma 7 tracking sustainer very easily in fly-by-wire low. And going to manual proportional. Sigma 7. I am now in ASCS auto, retro attitude, manual proportional, works very well. Canary Capcom, this is Sigma 7, over.
Sigma 7, this is Canary Comtech, transmitting HF, UHF. Do you read, over?
Roger, Canary Capcom, this is Sigma 7. Do you read me?
Sigma 7, this is Canary Capcom, reading you loud and clear. We have valid radar track.
Roger, good show on your radar. Awfully sorry our friend Julian couldn't be with us. I'd like to give you my report on control modes. First off, manual and fly-by-wire low are excellent. Aux damp was excellent. I am now in auto mode, retro attitude. Attitude's holding beautifully. I am go. My suit temperature is going up a bit. I have set it at 4.5. Over.
I copy. Suit temperature at 4.5. What is your suit temperature reading?
Negative. That was suit dome is reading 7.5. I have set the suit at 4.5.
Roger.
I am checking on my cabin. It's about 60. I'm going to leave it alone. Cabin heat exchanger is about 4.8.
Roger.
The Canaries, as far as I'm concerned, all control systems are perfect. The manual was slightly sluggish, as predicted, but better than I have seen.
Roger. Are you on UHF high at this time?
That is affirmative, and we'll be switching the UHF low for a check with you shortly.
Roger.
I have made an electrical check. We had comm problems on the way across, and all of these systems checked out very well. Oxygen is holding up very well. I'll give the suit circ a little more time to cool down. My suit temperature at this time is 6.8. I'm not worried about it yet.
Roger.
Everything else is green.
Roger.
I'm going to go to gyros free for a TS plus 5 check.
Roger. I have 2-1 retro sequence time if you want it.
Roger, stand by.
012821.
Roger, correction to 21. 012821.
That's confirmed.
Roger. Okay, it looks like the dome is coming down a little bit. I'll stick with this setting for a while.
Which dome is that?
That is the suit dome. The cabin dome is 5.5.
Roger, 5.
Canary Capcom, Sigma 7, you read.
I copy. Cabin dome setting at 5.5 and suit dome at 4.5.
Those are not settings, so let me go over that. Suit dome temperature is 7.5. Cabin dome temperature is 5.6. Suit setting on the coolant valve is 4.5. Cabin setting is 4. Do you understand?
I copy now.
Okay, going back to gyros normal, TS plus 5 confirmed.
Sure.
I see we're coming across the coast. I haven't used the periscope too much as yet.
Roger, are you on UHF high yet, low yet?
Negative. I will switch to low now before I lose you. Locks off. Canary Capcom, this is Sigma 7 on UHF low. How do you read? Canary Capcom, Sigma 7 on UHF low. How do you read? Tono, Capcom. This is Sigma 7 on UHF low. How do you read? Over. Tono, Capcom. Tono, Capcom. Sigma 7, UHF low. How do you read?
Sigma 7, this is Tono, Comtech transmitting on UHF, HF. Do you read? Over.
Roger, Tono, Capcom. Do you read me? UHF low. Over.
Roger, stand by this frequency 7 for Capcom.
Okay.
Sigma 7, this is Tono, Capcom standing by for your short report.
Roger, I am go. All systems are go. I am in ASCS auto. Maneuver is off. My TR -10 bypass is to normal. The fuel and oxygen are all green. Everything is green. I'm fat here. I'd like a CET time check.
I understand you want a CET ground check?
That's correct.
Roger. At my mark, it will be 22:10. Mark.
Roger, I'm right on. I am changing my suit setting to almost 5. Over.
Understand changing suit setting to number 5.
That is correct. The dome temperature is at this time approximately 77. I will leave it at number 5 for at least 10 minutes.
Capcom standing by for any further reports, Sigma 7.
Roger, Kano. Looks like you got good weather down there.
That's affirmed. Your attitude displays checked with your visual reference?
Very well. I noticed that the yaw reticle is performing quite well. I've been using it crossing land here.
Roger, understand.
I'm going to try some of the periscope now. A rather unusual sight through the periscope. Not as thrilling as through the window, I'll have to admit.
I understand.
Looks like we're coming up on some cloudy weather.
Our telemetry pitch attitude shows about 27 minus, and your scanner output shows about, minus 36.
Roger, I'm right on minus 34. It correlates with the window reference mark, and I feel quite content that we're right on.
Very good. How's your suit temp doing now?
The suit temp is now coming, still going up a little bit. It's about 7.2. I am setting at suit temperature of number 5, and I'll give it a little more time to try to cool down. As soon as I get a reverse and flow of this dome temperature, we'll have a cut at it, I think.
Roger.
Okay, we're picking up some pretty fair clouds now. Inverters look real good.
Roger, understand. What does your suit dome temp look like now?
It looks like it's holding. I may have to increase it after a little while. I'll let it sit for a while.
All TM systems look good, 7.
Roger, I think the only problem I have is the suit circuit. I'll work on it for a while and see how we are.
Takes a wee bit of time for that to stabilize.
Right, that's what I'm trying to do. The dome now is still holding at 7.8. I think I'll let it sit for a little bit longer.
Say again, that temperature.
The suit dome is 7.8.
Understand.
Cabin dome is 6.0. Cabin dome, Connor, this is Sigma 7, do you read?
LOS 7.
Roger. Cabin dome is working very well, it's just fluctuating.
Roger.
It goes between 5.2 and 5.8. And I owe Frank Szymanski, so far at least, 50 cents. I, at this time, have all three axes practically on retro attitude, and yaw through the reticle easily observed as a rate, and I'm now trying to check for a change in attitude in yaw. I do notice that one cloud even gives me an attitude immediately as a reference. It's almost too accurate for the actual observation that I have within the capsule. I'm now going to low mag, correction high mag on the periscope, see how it looks. Yaw is yawed right about 5 degrees. See how she matches up with the periscope at this point. Okay, we have on the yaw axis, I have about 10 degrees right at this time, and clouds are tracking right up the line, as if the yaw axis might be off by as much as 5 to 6 degrees. Now, this may be a minor problem. We'll have to observe it.
Sigma and HF in.
Hello, Kano. This is Sigma 7. You're coming in broken, but clear. Over.
Sigma 7, stand by for Capcom. Over.
Roger.
Sigma 7, Sigma 7.
Kano, Capcom, you're coming in weak and broken. Over.
Zanzibar, Capcom, over.
Roger, Zanzibar. Sorry, I miscalled you. I'm going to set my suit setting on the coolant valve to 5.5. Over. Zanzibar, this is Sigma 7. You read.
7, this is Zanzibar. You were cutting out. I didn't get your last message. Would you repeat?
Roger, stand by, switching to UHF high. Hello, Zanzibar. This is Sigma 7. How do you read? Over.
7, this is Zanzibar, Capcom. Read you loud and clear. Now go ahead.
Roger. I have set my suit control valve to 5.5. The suit dome temperature is 80. Over.
Roger, understand.
The cabin dome is 55 and is apparently under control.
Roger, understand.
My suit temperature has come down to 7.5 at this time. In fact, that's a correction. It hasn't come down. It's just gone there. I would like to give you a briefing on my control mode. I am in auto mode. The bypass switch is normal, maneuver off. Fuel is in the green. Oxygen is way in the green. All electrical is in the green.
Roger, 7. Your 2-1 retro sequence time is 012821. Over. 7, Zanzibar.
Oh, Roger, I'm sorry. I was trying to get my card out. I understand 012821. Okay.
Zanzibar.
Go ahead, Zanzibar.
All systems are green.
Roger, Zanzibar. I'm all green here. I'm still working on the suit circuit.
How do you feel? Uncomfortable?
I feel quite comfortable. I'm a little warm, particularly from sunlight. But other than that, I feel fine.
Roger.
I am holding the suit control setting at 5.5 for a little longer.
volcano, is affirmative?
That's correct. Looks like you've got pretty good weather down there, too.
Good, very good.
Got a lot of good clouds for yaw checks, I'll say that. Would you check your reading on what you read for me in yaw at this time?
Roger, we're getting about a plus 5 degrees, over.
Roger, concur. And I'm trying to come back towards 0 now.
Roger, we're pulling you right back to 0 now.
Okay, that's the ASCS system doing it for me, of course. I'm going to have to increase this suit setting. I'm just barely breaking even. I'm going to set the suit control valve to number 6.
You understand 6. It's been about 10 minutes.
Roger, thank you. The cabin is holding very well on settings. I'm perfectly comfortable there. Negative. I will keep the suit setting at this point until it gets a little hotter. If it does, I may go up another half a notch at about 4 or 5 before I get to Woomera.
You understand? I'd like a reading on that before we get LOS, please.
Roger, my suit setting now is 6. The dome is 8-1. 8-1.
All systems are still performing well here on the ground.
Roger. This is Sigma 7, somebody broadcasting in the blind. I do not read you too well. Roger, you're garbled. I will give you an HF call shortly. This is Sigma 7. I read you. It's rather very garbled. I did not observe my HF antennas on turnaround. The rates were just too much small, I assume. I'm going to switch now, Vox off, and go to HF. Canary contact, Canary correction. Zanzibar, this is Sigma 7 on HF. How do you read? Over. Hello, Mushe, Capcom. This is Sigma 7, HF. How do you read? Over. This is Sigma 7. I have noticed minute objects that I can knock off the capsule 1 or 2 in the bright sunlight at CET 4110.
Bradley, read your HF check, over.
Roger, Zanzibar. I read you loud and clear at this time. That is at 4130. Zanzibar came in HF loud and clear. Mushe Capcom, Sigma 7, HF, over. I'm switching to push to talk. Mushe Capcom, Sigma 7, HF check, push to talk, over.
UHF were none. No HF reception during the pass. NOS was at 125300. 125300. He talked to Brian after we finished, and iOS picked him up. Out.
The last station that talked on HF I could not identify came in very clear and should be recorded aboard the capsule at approximately 43 minutes, 10 seconds elapsed time. I have switched to Vox, transmit and record. I am satisfied that I can see yaw through the window on ASCS without the use of the reticle by letting images come up from all sides. It's only a matter of a short period of time before objects show translation immediately. The pitch scribe mark does indicate up a little bit, and as a result matches the retro attitude, which at this time is 30 degrees. I am now yawed right, approximately 10 degrees, and it looks like I'm tracking right down the line. I am at 4 or 5 minutes. I am going to increase the suit setting knob just a small amount, about a quarter of a turn. I think we almost have control of the situation. I have set the suit knob at 6.25. The dome temperature at this time is 8.2. Suit inlet is 7.6. I definitely can see a right roll at this time of about 5 degrees. And I notice that the periscope is dark, meaning we are coming into the dark side. I will attempt to look for the changes with the periscope for any observation. At this time I can see nothing through the periscope for a night observation, at least in this attitude. I'm not even sure when I have low mag, it's other than the position of the lever. The window is cloudy. I have sunlight on it now, and it definitely has been clouded over by the escape tower rocket. Not to a great degree. I am seeing the so-called fireflies just sporadically at this point. I tried a couple of knocks, and they definitely have a relative velocity to the vehicle, but apparently are part of the same orbital system. I definitely see them as white objects. I would like to take some water to drink at this point, but I'd rather keep the visors shut to keep the system attempting to cool down. We may make some progress on the cold side. It looks like I'm going to have to decrease the cabin. It's going down to 45 dome. I'm coming to 3.5 on the cabin. Checking on inverters at this time. They look very good. One 150 is 102, 250 is approximately 107. Going back to cabin heat exchanger. Coming into the night side now at approximately 47 minutes elapsed time. I set the cabin suit to 3.5. The suit dome is now just correction. The cabin dome is nearing 50 again. I will leave that setting at 3.5 for a period of time. There's much sunlight, I cannot see stars at all. The sun is off to my left, and I'm getting close to sunset. Approximately at 4:09 is the scheduled time, and just about right on. I'm approaching 4:09. The cabin lights are on white. I'm going to switch the cabin lights to red. And turn off that blasted liftoff correlation clock light. Oh, I almost missed my first sunset trying to get the right cabin light off. It is rather rapid, as I was told it would be. I am not able to... There, I've got Arcturus right on the right side where it belongs. Very nice. I should be able to pick up Miche shortly at 50. Having trouble seeing the clock at 4:09 minutes.
Sigma 7. This is Miche Capcom. Do you read, over?
Miche Capcom, Sigma 7 HF. I read you loud and clear, over.
Roger, you are loud and clear also. How do you feel?
I feel very good, Gene. I'm on HF at this time with the dipole. I've readjusted the cabin setting. The dome went down to about 4 or 5 degrees. I set the cabin at 3.5 as a cabin coolant valve setting. Do you understand?
You set the cabin at 3.5, is that correct?
That's right, because it's reading a little low. On the suit, I am now at 6, and I'm going to increase to 6.5. I'm not making much progress. I went up to about 6 1/4 about 5 minutes ago. I'm now setting the suit control to 6.5. The dome is reading 8.2.
The dome temperature on the suit is 882, and you have just now set to 6.5. Do you feel too hot or anything?
No, I have beads of perspiration on my lip. That's about all.
We have suit temperature. Roger.
Say again?
Roger, go ahead with status report.
Okay, I am in auto mode at this point. Everything is acting perfectly. The maneuver switch is off. The systems are all green. I'm practically using no auto fuel. My only problem area is the suit circuit, which I'm monitoring very carefully.
Roger, Sigma 7. I'll now give you an emergency voice check. The next transmission will be on emergency voice.
Roger.
Sigma 7, this is Boucher, Capcom on emergency. Do you read, over?
This is Sigma 7, read you loud and clear, Gene, on emergency voice. Very good. I'm setting it down at about volume level 4.
Roger.
I'll give you a blood pressure. Roger.
Has anybody asked you yet to drink water, Sigma 7?
Negative. I've tried not to get into that. If I can get the suit temperature down a little bit, I'll open the visor and get some water in.
Roger, understand. Status of the Woomera flare test is okay. They're going to light them, but there is broken cloud and light rain. No lightning reported. They will fire flare.
Is the place covered with clouds, over?
Negative. Broken cloud, the last estimate I got was 8 tenths and several breaks.
Roger, understand.
Sigma 7, will you give us a cabin heat exchanger temperature, please? Over.
Roger, that is 41 degrees, over.
Roger, understand. Your body temperature readouts on the ground are no good. We are not paying any attention to your body temperature readouts, over.
Roger, I understand.
Sigma 7, this is Boucher. What is your suit dome temperature again?
It is now holding at 8.2 at a coolant setting of 6.5, over.
Being interfered with there, will you repeat?
Roger, my dome temperature is 8.2. My coolant...
0.
8.2, number 8.2.
Sigma 7, your transmissions are now very noisy. We will stand by and not contact you for a while. You are due to contact Woomera in about 3 minutes.
Roger. Now, Woomera, this is Sigma 7, over.
Go ahead, Sigma 7.
Is this Boucher or Woomera?
Boucher, you're coming in much better now.
Roger, I have the moon right in the center of my field of view. It's a marvelous yaw reference, just no sweat on it at all.
Roger, understand. Very good yaw reference.
That's affirmative. I'm still on automatic control. I'm going to switch to fly-by-wire shortly.
Roger, we'll stand by and report.
I am switched. My cabin is working okay. The suit is okay. I'm going to come down for the yaw check correction for the flare check now. I'm pitching down and fly-by-wire low.
Roger, understand.
Fly-by-wire low, working very well. Trying to hold minus 40. Correction, minus 50.
Roger.
Heading at minus 50, gyros are free. Holding at minus 50, standing by for flare. Roll and yaw are holding. I see the flare on my left, which is kind of wrong, I think. I think I saw a flash of lightning, probably. That is lightning I'm seeing, not the flare. I'm seeing more lightning. It's going to be hard to tell what I'm seeing, whether it's lightning or flares.
Sigma 7, this is Woomer, Capcom, over.
Roger, Woomer, go ahead.
Woomer, Capcom, flare ignition will be in 1 minute 20 seconds.
That's one reason why I can't see it, because I'm looking at lightning, obviously.
And I didn't receive your gyro switch position.
Roger, I am in fly-by-wire low, and I have gyros free.
Roger.
There seems to be no trouble at all in tracking the gyros. There was a large problem for me in trying to get the right cabin light dimmed down to red. It's very hard to reach through the ditty bag. I had not even messed around with the camera. I don't intend to until I have the suit circuit under control.
Roger, you have 5 seconds to flare ignition.
Roger, I'm tracking minus 50 degrees pitch.
Ignition now.
Roger, I have lightning only. It looks like you're just about socked in. I'll stay here for a while and then come back up to ASCS shortly. I think I saw lightning right below me, but it couldn't have been the flare. It should burn steadily as I understand it.
Correct.
The lightning looks like a big blob rather than a jagged streak that we're used to seeing when earthbound. It just looks like a big, almost like a anti-aircraft shot, a big flap of bright light, and then it fades out almost instantaneously. It definitely looks like you are overcast. By the way, how is my HF coming through to you all?
Clear, it's Woomera.
Very good. I'm on HF and dipole, as you may know.
In fact, we picked you up when you began working Mouche.
You did. Very good. Well, looks like we got the poles out.
Right.
I think I'm going to, between you and can time, we'll make another attempt at the suit temperature control. We definitely aren't making much progress. I'm holding my own, that's all.
Roger. You're picking up a little plus yaw now.
Roger, I concur. I was looking for the flare. Are you lit now?
Affirmative, they are ignited.
Roger, I've got a steady light in sight. That's because I pitched up, though. Now, it looks like we're getting much clearer weather here. And I must have some ground lights inside here. Very good. I've been searching around a little bit for this. Okay, I'm going to hold that pitch still now. Holding the yaw still. Stopping roll. And I'm sorry, I can't see your flare. I'm going to start pitching up for ASCS.
Yeah, 10 seconds, so flare is left, and Chief's requesting your suit temperature.
Say again.
Requesting your suit inlet temperature and dome temperature.
Roger, my suit inlet is 7.8. My dome temperature is 8.2.
Sigma 7 and former at that time, your transmission not received.
Roger, my suit inlet is 7.8.
What is your suit and dome temperature?
This is Sigma 7. I say again, my suit inlet temperature is 7.8. My suit dome is 8.2.
Okay, we got that.
Roger, I'm going to increase my setting to 7 on the coolant control on the suit. I am now in automatic mode. Gyros are normal.
Suit setting 7.
The suit coolant valve setting is 7. That is correct.
Your and attitudes agree here.
Roger, I am in orbit mode and tracking very well.
Roger, we've had TM LOA. Correction, we've got it back.
Roger. I am going to decrease the cabin setting. It's still running a little cool.
Roger.
I will set the cabin at setting number 3.
Roger, number 3 for cabin.
It is set now, Mark, at number 3. And the suit is riding at number 7.
Roger. And rumor has had TM LOS. We're standing by HF.
Roger. I'm definitely seeing some lights at this time under the overcast, and I'm sure it must be one of your major cities, possibly Brisbane, I'm not sure.
All we got was under the overcast on that transmission.
It looks like a city under the overcast, I'm not sure. At about, it's almost right in the middle of the window at this time. This is Sigma 7, going to fly-by-wire low and pitching up to re-entry attitude. Selecting re-entry on attitude select. I am now in re-entry attitude, standing by to go into automatic mode. Fly-by-wire tracks absolutely beautifully, just as it would in the trainer. Very positive results from using the procedures trainer. There's no doubt about it, time does pass rather rapidly, going back to automatic mode. I get a pitch down signal, just a slight low thruster, and everything seems to be all right. This probably was a slight error in the corrected readout. I was right on, I believe, in all three axes. The capsule logic is working very well and is tracking very well in re-entry. I will check my time. It is 1 plus 0650 seconds when I went into re-entry attitude. The stars are very easy to see. I see quite a few, but am bothered by a considerable amount of red light. I'm now going to devote some attention to the suit circuit for a minute or so, and then prepare to go back into retro attitude for Canton. One definitely gets the illusion of looking way up above you at this attitude, in that there's no horizon, it's just a black sky. The amount of light in the cockpit is quite high once one gets adapted, and it can be reduced, of course, by the cabin light. At this point, I am somewhat reluctant to reduce the light level in here due to the problem with the suit circuit. I'm using my fingertip lights liberally. It is apparent that in future flights, they must have some catch-all device that we can stuff objects into and have them trapped there for a period of time. I'm driving at the problem of the washer and small crimped piece of metal, which I believe I finally got stuffed into the little bag on the hatch. The temperature is just holding its own. I am hot and probably will have to decrease these settings. I'm sure I don't understand why the suit circuit takes so long to react, while the cabin circuit works beautifully. I'm going to go back to fly-by-wire low, select retro attitude, and fly to retro attitude.
Sigma 7, this is Canton contact. Do you read, over?
Canton, this is Sigma 7, I read you. At this time, I am in fly-by-wire low, pitching down to retro attitude for ASCS, over. Canton, Capcom, Sigma 7.
Sigma 7, this is Canton contact. Do you read, over?
Canton contact, this is Sigma 7. I read you loud and clear. How me?
Sigma 7, this is Canton contact. Do you read?
Canton contact, Sigma 7. Read you loud and clear.
Sigma 7, this is Canton contact. Do you read, over?
Canton contact, this is Sigma 7. Read you loud and clear. How me? Canton contact, Sigma 7, loud and clear. How me, over?
Sigma 7, that's the one, Capcom.
This is Sigma 7, go ahead. Canton, Capcom. This is Sigma 7. How do you read me? Over. Canton, Comtech. Canton, Comtech, this is Sigma 7, UHF high, over. Canton, Comtech, this is Sigma 7. I am on UHF high. How do you read, over? Canton, Comtech. Canton, Comtech, Sigma 7, over.
Sigma 7, this is Canton, Comtech. I read you 3 by 3. Over.
Roger, status report. I have sent you a blood. All systems are green, but for suit circuit, which I am working on carefully, I am in ASCS retro attitude, gyros normal, maneuver off. I am working on the suit circuit. I am still holding setting number 7. Over.
Sigma 7, repeat. I got your status green ASCS retros. Gyros are normal. Holding at 7. Repeat all others.
Roger. I am holding the suit coolant valve setting, George, at number 7. Over.
Say again, holding suit at what? At what?
The coolant valve setting is at number 7. The coolant control valve for the suit circuit.
Roger, Sigma 7. Would you give me your standard report again? Over. This is Canton, Capcom.
Roger, Canton. You did read that I was in ASCS retro. You did read that I had my maneuver off. You did read my gyros normal. I'd like to get the suit circuit discussed. Everything else is green.
Roger, Sigma 7. Go ahead.
I have the suit setting for the control valve at number 7. I have the suit dome temperature at 8.2. I have suit inlet at 7.8. Do you understand?
Roger, Sigma 7, I understand.
I am increasing my suit setting at this time to 7.5. Over.
Roger, Sigma 7, understand increasing your suit setting to 7.5. Over.
That is affirmative.
Sigma 7, request you push stop button on blood pressure. Over.
I have done that. Well, I guess it didn't come through right. Did that clean up the trace? Over.
Say again. Over.
Is your EKG okay now?
Roger, Sigma 7. Sigma 7, how do you feel right now? Are you hot?
Not uncomfortably hot, just a little warm. I'm trying not to take a drink of water until I can get the suit circuit under control. If I can't get under control right away, I'll be drinking some water.
Roger, Sigma 7.
Canton Capcom, Sigma 7, over. Boy, this is a wrestling job with this ditty bag. Just as soon I even go into it. Finally got one dosimeter out. And we'll have to put it up on the hatch, and it's the Never Mark one. I can't even see anything on it. It's a Sigma 7 on UHF high. Does anybody read? Over. Box off. This is Sigma 7 on HF. Why do you read? Over. Hawaii, you're coming in broken. I cannot read you. I am handling HF at this time. Over. Jupiter, huh? Wireless Capcom, this is Sigma 7 on HF. Do you read me? Over. Hello, wireless Capcom, Sigma 7, HF, over. I'm now starting to see the sunrise in the periscope. First light in the periscope during this particular orbit as a result of the night side. It is obvious that the periscope has no function whatsoever in retro attitude on the night side. The first light that I get is right now at a CET of approximately 1:25, 1 hour and 25 minutes. Sunrise is coming in rather rapidly through the periscope. I do have the lighted objects that John mentioned, and I can create some by knocking them off. I definitely have a sensation of there being a field and varying in size from small to bright. The periscope itself is blinding me. I'll have to put the chart on it so I can see out the window. I am in condition for retro at any time, so I have nothing else to do but look out this window, assuming that the suit circuit is satisfactory. That chart helps no end to cover up that blasted periscope. Now, it's quite a large field of these objects. It definitely is, and you can knock them off the hatch, as Scott has said. And they stream off. Definitely, there's no problem in judging that they are going away from the capsule at a different rate than you are. They're definitely slower in velocity than the capsule itself. One rap, and you can see them sliding aft. They're too small an object for photography. I wouldn't even attempt to take a picture of them. Retro attitude is being held very well by the ASCS. I should be able to reach Wymus by now. Wymus Capcom, this is Sigma 7, over.
Guaymas, Capcom reading you 3 by 3. Give me a quick rundown on how you feel, Wally, and your suit at dome and inlet temperatures, please.
Right, Scott, I feel fine. I'm sure we're getting in on this suit circuit. The dome temperature is holding now at just about 8.1. I'm making a change in it. The suit inlet temperature is at about 7.8. I think another cut at the control will solve this problem.
Roger, say again your suit inlet temperature, please, and what is your control setting?
Roger, the suit inlet is 7.8 degrees. The setting is exactly 7.5 on the suit control valve.
Roger.
Scott, I feel we're in very good shape for one more orbit at least, and we'll see how we can hack this suit circuit here.
Understand, Wally. We have a go. Are you ready to copy 3-1 and 6-1 times?
Roger, stand by. Okay, Scott.
Roger, 3-1 is 030120.
Oh, back to 20 now.
Roger.
Okay.
Is 085133. Read those both back and give me a standard report, please.
Will do. Okay. 3-1 is 030120. 6-1 is 085133.
Report, please.
Okay, stand by. I'll stow this pencil. I am in chimp configuration. The capsule is flying beautifully. All thrusters are working well. The gyro switch is normal. Maneuver switch is off. All systems are green. I'm green, and I'm bird dogging the dome temperature at this time on the suit circuit.
Okay, Wally. Wally, give me your cabin dome and cabin temperature. Also, your flow control setting on cabin, too.
Okay. I have cabin temperature 100, cabin dome 40, cabin heat exchanger is 42, the setting on the cabin is 3, and it's holding steady for a long period of time. I'd rather not change that.
Okay, and now your fuel and oxygen, please.
Okay, you want numbers?
Sure.
Okay, the numbers on fuel, 100 for auto, 95 manual. Oxygen is 6.2 primary, 7.2 secondary.
Roger, and on my mark, the ground elapsed time will be 1 hour, 30 minutes, and 10 seconds. Stand by, mark.
I am exactly 1 second slow. Correction, I am 1 second fast.
Roger, understand 1 second fast, and looks like you're good for another one, Wally.
Okay, I saw some of John's friends up here, I'm afraid to say, although I knocked them off the way you did them.
You're interested in your report.
Right, I imagine John's listening for some of that, too.
All right.
Basically, what I saw was the firefly color that John saw, which I could create at other times as white color. I'm definitely convinced it's a capsule derivative, and once in a while, even now, I see one go by.
Roger, that's good to hear.
Getting a very good yaw check with the yaw reticle in the ASCS mode. Having no trouble with it at all.
Okay, are the particles luminous or reflecting?
I think they were reflecting. I'm going to go ahead now, Scott, and do some yaw checks as long as I've got some good terrain to look at, and leave the particles off for a while.
Okay, we are just about losing TM. We're reading roughly 0, 0, and 34 at this time.
Roger, I understand. This is Sigma 7. I am now commencing day yaw checks. Glamis, do you read? Over. That's a Sigma 7. I am going to send that blood pressure at this time.
Oh, Sigma 7, Glamis Capcom, reading you on HF.
Roger, I'm going to fly by wire low at this time.
Roger, you're loud and clear on HF now, Wally.
Roger, Scott. I moved my left arm too much on that last transmission. I'll give another one a little later.
Roger. Sigma 7, Cape Capcom, are you read?
Hi, Deke. I read you loud and clear. How may?
It's coming fairly good.
This reticle is working very well for yaw as well as for almost any other attitude. Go ahead, Cape. Cape Capcom, go ahead. Cape Capcom, this is Sigma 7. I read you loud and clear. How may?
Cape, Capcom.
This is Sigma 7. Go ahead, Cape. I read you loud and clear.
You're coming in about 3 bars.
Okay.
What?
I am, okay, stand by. I'm going back to ASCS. This is going to hold me up. The capsule, I'd like to straighten out this problem that you obviously have seen on the suit circuit. I have had very little luck in bringing it down. I'm going to increase the setting to 8 at this time. I am on 8 now. The suit dome is now about 8.1. It has dropped about a degree. You understand?
Understand, suit valve is 8, dome 8.1.
That is correct. Suit dome is 8.1. The suit inlet is about 7.6. I'm making a little ground on it.
That sounds promising.
Yeah, I think it is. I didn't want to rush into it, and I didn't get too hot. I know you were concerned, but I'd rather come up on the right setting than dick around going back and forth.
Roger.
Now, all the systems are working very well. I'd like to give you a rundown on the control systems. Fly-by-wire is excellent. Manual was slightly sluggish, but very good. The capsule at this time is in auto mode. Maneuver off, gyros normal. PS+5 did check out very well. The fuel is holding up, as you can see, as well as the oxygen.
Yeah, sounds good.
Okay, I'm going to continue with my day yaw checks now.
Next transmission will be on emergency voice.
Roger.
Sigma 7, Cape Capcom, transmitting emergency voice.
Roger, I read you loud and clear. I'm going to send you another gadoozer here because I moved too much on the last one.
Right. Capcom.
Go ahead, Deke.
2 Bravo, retro.
Stand by till I finish my blood here. Okay, I'm done. Okay, go ahead with your 2 Bravo.
2 Bravo, 014833.
4832, is that correct?
014833.
32, Roger, understand. 014832, 2 Bravo.
Can suggest you had a drink of water if you haven't had one recently.
No, I haven't. I tried not to open the visor. I want to get the circuit going down. I think we might have a chance to take a quick one. I'll get ready for one.
Okay, if you're reading this, I want to query you on one item.
Oh, okay.
I've indicated high thruster action at Bermuda and Mouchet on switchover from ASCS to fly-by-wire. Has this been apparent to you?
Negative, it has not. I had one case where I went into re-entry attitude after correction before Canton. This was to check the stars at night after Woomera, and I got a twitch then, which I think was a high thruster. Otherwise, it dropped in beautifully on transition from control mode to control mode.
You're very poor on transmitting. Let's try UHF once.
Okay, stand by. Box off. Deke, I read you loud and clear. How me?
I read you.
I read you fine. I just had some water, and it does feel kind of good.
Much better.
Say again?
You're much more readable on UHF.
Okay, we'll use that around the path.
I have some echo sighting data for you if you're interested.
Yeah, I'd like to hear about it.
Okay, second orbit over Zanzibar. Time 14:23 Zulu. Alpha should be 2.30, elevation 83.25.
Roger, we'll see if we can take a peek at it.
I would recommend you decrease suit valve to position and observe dome temp for 15 minutes. If this doesn't help, go back to 7.
Deke, I finally got a grasp on this thing where I'm beginning to feel a little cooler, and the suit inlet temperature is now down to 7.6. Over.
I understand you prefer to maintain the status quo, is this correct?
Right, I've been sneaking up on this thing for almost a whole orbit. You understand? Cape Capcom, Sigma 7.
Go ahead.
I really do feel I'm getting cooler. The suit inlet is now about 7.5 to 7.6. So I am making progress. Over.
I understand. You are getting a slight decrease.
That is affirmative. I'd rather not throw in the sponge on the settings I have so far.
I understand. You prefer to let it stabilize a while longer.
Right. I'm going to go back to some more yaw checks. Going to fly-by-wire low.
Fly-by-wire low.
Roger. Go ahead, Dick.
Again shows high thrust reaction. I'll switch over to fly-by-wire.
I'm positive I'm not getting it because I'd be leaping all over the sky if I were getting highs at this point. I haven't used more than a half a degree per second. Go ahead, Deke. Go ahead, Cape Capcom.
As you are stating, we are about at LOS. Flight would still prefer that you consider going to position 3 after evaluating 8 a while longer.
Roger, understand. Roger, I'm now getting into attitude. Stand by for 0 yaw and pitch and roll. This will be yaw is now approximately 0 at this time. Mark. I will look. I have about 4 degrees left. Correcting in pitch. Yaw is okay. Trying to go back to ASCS to get gyros straightened out. Gyros are normal at this time. I'm setting up into a tight pattern. Rates are just about right on. Attitudes right on. Going into fly-by-wire. Gyros normal. At 144.50 approximately, we are back into chimp configuration. And I would have LOS at Bermuda. Next station is Canaries. At this point, the suit temperature is down to 7.5. Dome is still high. On the 0 to 50, on the 0 to 50 Roentgen scale at 01 hours 46 minutes, there is practically no reading at all. Hello, Canary Contact. This is Sigma 7. I read you loud and clear. How may, over?
Roger, Sigma 7. This is Canary Capcom. Read you loud and clear. We'd like to get some temperature readings from you, cabin suit, and cabin dome and suit dome. Over.
Okay, I'll give you a readout. Suit dome is 80. Suit inlet temperature is 75. Cabin dome is 41. Cabin temperature is 97. Suit coolant setting is 8. cabin is thru. I will follow.
Do you feel these settings now are giving you adequate cooling?
I am going to take flight's suggestion and reduce my setting to unit 3 for a few minutes and then try back at 7 if this does not work. Over.
Roger, I copy.
I am now going to setting number 3 on the suit temperature control.
Roger.
At 1 hour and 50 minutes.
Roger. What is your present mode?
I am in ASCS. I have completed yaw checks with the window. I am going to try some yaw checks with a periscope at this time. Switching to fly-by-wire low. Arrows free. I can definitely see a yaw pattern in the window, in the periscope, in the reticle. The window itself is satisfactory at 34 degrees. I've covered the gyro. I'm now coming back to the left to remove yaw.
Roger, how far did you have to come back on yaw?
I am not there yet. Let's say about 25 to 30 degrees. I'm stopping yaw at this time. The periscope checks with the window and the reticle. I'm going to give a mark shortly, just trying to get all rates stopped. I'm just about in retro attitude now, and yaw looks real clean. I'm going to pull off and look. It's about 1 degree of yaw. To the right. Mark. Okay, I'm satisfied with that kind of day yaw check. That was done in retro attitude. I had a real good cloud layer. That's what was the cue.
How do you feel about systems at the present time now?
All systems are green except for the suit cooling, and it definitely is, the dome temperature is going up at this time. I'm going to go back on ASCS for a while and hack out on that one.
Roger.
I will not go to ASCS. By the way, how about taking a look at my high thrusters when I'm... Have you seen any high thruster action at all?
Stand by.
I shouldn't have had any at all.
Did you already switch to ASCS?
Negative, I have not switched.
Wait now.
Say again?
Go ahead and switch.
Oh, I'm good. Have I had any high thruster action so far?
Negative.
Okay, that's good. I'm still on fly-by-wire low. Stand by. Switching now. Plop. I'm going...
Thrusters.
What, say again?
High thrusters.
Okay, good deal. Going gyros normal.
Roger. That is a firm here.
I have completed my day yaw checks, and I'm very satisfied with the technique of taking care of roll as I arc.
Sigma 7, Sigma 9.
That's a Sigma 7. I'm going to have to give up on this lower temperature. Everything's going up.
I'll report that to the case.
I'm going to set into number...
Sigma 7, this is Kano, contact transmitting on UHF HF to you.
Roger, Kano. I read you loud and clear. How me?
I'm reading you here. What's the new setting number?
Okay, I'll set it back to 7.5.
Roger, I copy
7.5.
The suit dome went up to 82 degrees.
Sigma 7, this is Colonel Contact transmitting on UHF. HF, do you read, over?
Did you read me, Canaries? Hello, Cano. Hello, Cano.
Sigma 7, this is Colonel Contact transmitting on UHF. HF, do you read, over?
Cano, I read you loud and clear. How me, over?
Sigma 7, this is Colonel Contact transmitting on UHF. HF, do you read, over?
Cano, this is Sigma 7. Read you loud and clear. How me, over?
Roger, 7, I read you weak but readable. Stand by this frequency for...
Okay.
Sigma 7,
I read you loud and clear. I don't know whether Canaries got my last on the suit system. I got 82 degrees on the dome and went back up to a setting of 7.5 on the coolant valve. Over.
Sigma 7, Colonel Capcom.
Go ahead, Cano. Cano, Capcom, Sigma 7, go ahead. Hello. Hello, Cano, Capcom, Sigma 7, over. Cano, Capcom, this is Sigma 7, go ahead.
Sigma 7,
Cano, Capcom, this is Sigma 7, go ahead.
Sigma 7, I don't read you.
Roger, Cano. This is Sigma 7, I read you loud and clear. Sigma 7 switching to HF.
Sigma 7, Colonel Capcom. Cape, we have no air to ground at the present time.
Cano, this is Sigma 7, over. Hello, Cano, Capcom, Sigma 7, over.
Roger, Sigma 7, I have not read your transmissions, over.
Roger, I had to switch to HF at this time. I am on Vox at this time, HF. How do you read?
Negative 7, would you say again?
I am on Vox. Correct. I am going to push to talk on HF. Do you read me now?
Roger, I'll read you better now.
Okay, do you want some suit stuff?
Roger, how's your suit doing?
Okay, I've already caught the dome temperature. It went up to about 8.2. I've got it back to 8.1. The suit inlet went up to 8.0. I've got it back to 7.8. I am back at a setting of almost 7.5 on the suit selector. I'm going to setting number 8 at this time.
I understand you're going to number 8 on suit setting.
That is correct.
Would you say again your suit temperature?
The suit temperature at this time is dropping slowly. It is now 7.7.
Rising?
Negative. It is dropping, lowering.
What is your dome temperature?
It is coming down. It is now 8.1.
Roger, I copy.
Okay, I think we got locks on it by going higher in settings.
Say again your garbled?
I think we have the situation under control.
Roger. What is your short report?
I am now in ASCS. Gyros normal. Maneuver off. All systems green, I'm green.
Roger, understand auto retro.
That is affirmative.
Our telemetry shows pitch attitude of 2.5 negative, and our scanner shows 3.6 negative.
Roger, your scanner is correct. I am indicating 3.6 negative, and it checks with the window.
Time. Sigma 7.
Go ahead. Go ahead.
Stand by for Charlie retro time. Sigma 7. Call Capcom.
Go ahead, I'm ready to copy. I read. Go ahead, Connor.
Sigma 7.
Connor, this is Sigma 7. Go ahead.
Transmitting in the blind. Sigma 7. Charlie time. 0430. Sigma 7.
This is Sigma 7, Roger, 02043042 Charlie.
Sigma 7, come in, please.
This is Sigma 7. I read you loud and clear, Helmy.
Read you now. Did you get my 2 Charlie time?
Roger, 020430.
Would you say it back to me?
Roger, 020430.
That is Roger. How's your suit temperature now, 7?
It is now coming down to about 7.6, and the dome is 8.0. We're going in the right direction.
Is your cabin temperature holding?
Cabin temperature is under control. It is 9.5, 905.
Roger. How do you feel?
I feel very comfortable now. I'm cooling off at last.
Very good.
I'm going to manual proportional at this time.
Are you going to power down?
Negative, this is manual proportional.
Roger, understand. TML West 7.
Roger.
Do you read?
This is Sigma 7. I read you still.
I read you very garbled.
Roger. Gyros are free.
Captain UHF. How do you read, over?
Sigma 7 on HF, read you loud and clear. How me? Zanzibar, Sigma 7, over.
Sigma 7, this is Zanzibar. I'm not reading your signal. What are you transmitting on, please?
Sigma 7 on HF.
Sigma 7, this is Zanzibar Capcom. Do you read, over? Sigma 7, this is Zanzibar Capcom. Do you read, over?
Zanzibar, this is Sigma 7. I read you loud and clear. How me, over?
Well, Roger, I'm not reading you. Very, very weak. Would you report the system control setting now, and how do you feel?
This is Sigma 7. I feel marvelous. We have finally got suit control. This is Sigma 7. I had a slight case of double authority there. I got very bored with manual proportional during a drifting period and forgot to put the rate command switch to auto. This is about 1 stroke in pitch. Zanzibar, this is Sigma 7, over. Zanzibar Capcom, Sigma 7, over. Zanzibar Capcom, Sigma 7, over. Zanzibar Capcom, Sigma 7 on UHF, over. Indian Ocean ship, Sigma 7, over. Indian Ocean ship, Sigma 7 on UHF high, over. Indian Ocean ship, Sigma 7, over. Indian Ocean ship, this is Sigma 7, I read you, how do you read me, over?
Do you have anything at this time, over?
Roger, I have good news. The suit dome temperature is now 70 degrees. The suit inlet temperature is now 70 degrees, over.
Surgeon wants to know if you feel particularly hot, over.
Negative, I feel very comfortable. Did you read what I've got for the suit temperatures?
Oh, Roger, understand. Sigma 7, this is IOS Capcom standing by, over.
Roger, I want you to read back what temperatures I gave you on the suit dome and on the suit inlet, over.
Roger, suit temperature as 70. Suit inlet temperature as 70, over.
Roger, the dome is now about 63 degrees and is holding fairly steady. I will monitor it so it doesn't go too low.
Roger, 63 dome, holding steady, over.
Roger, I think we got that problem licked. Roger, everything is good here. Thank you very much for waiting for me to come by again. Hi, Wes. This is Sigma 7. I'm not sure whether you realize, but I have been in auto mode retro attitude. Over. At last we have solved the suit circuit temperature problem. I can see why Scott's concerned about this record position only. There is no side tone as well. The suit temperature at this time at CET 217.20 mark is 68 degrees, and I'm feeling marvelous. The suit dome is about 72 degrees again. Apparently it does fluctuate, and we are going into the night side at this time. I believe we have the suit circuit under good control. I will go back to Vox push to talk. Standing by for Miche at 2:05. Gotta watch one sunset. Sunset is rather striking. I don't think that I need to waste much time looking at them. They are very interesting. The other thing that's fascinating is how black it is when your eyes are not adapted. I definitely can see some coating on the window. Going back to Fox at this point in UHF high to transmit. Opening visor to wipe off the right microphone. I licked it. Closing visor. Visor was sealed immediately. The suit circuit to go to work for me. I don't want to get fouled up with it again. The suit inlet is holding very nicely at about 6.8. So the dome again is starting to go back up. It's now up at 7.6, 7.5. Apparently this higher setting is the one we want. I think I'll put in another half a mark on that there, and we may have her locked. She's getting, actually I'm cool at last, so I know where I want to go with its setting. I have set the coolant quantity for the suit, the control lever, at 8.5 at 2 hours and 19 minutes, 28 seconds. The readout, the dome at this time, is 7.5. The suit inlet is 6.8, very pleasant. I can feel cool air crossing my face. The oxygen quantity looks real good, 6.0 and 7.5. I've been watching the 250 inverter. It is approaching 140 degrees, and the 150, in contrast, is down to about 100 degrees. Standby is about 100, which is cabin temperature. Currently, the 250 is the only one that's suffering, and I'll keep an eye on it. Cabin heat exchanger is definitely settling out at 40 degrees, and has given me a hard time because I obviously owe Frank Szymanski 50 cents. I'm pleasantly surprised. Cabin PO2 is reading a little high. Let me see now. We're carrying 5 psi. It's reading about 5.3. That's not too high with this cabin. Getting nice and dark out. I think I'll take a peek out for some stars at this point. The cover for the battery for the flashlight on the left glove is coming loose, only where the switch is. This is no problem, just a case of things wearing out before they should. Checking my wristwatch as a backup. I have 2 hours and 51 minutes. Correction, that's 2 hours and 21 minutes. Checks out. 2 hours and 21 minutes and 45 seconds. Right on. 52. But not too bad. We better get a CET check at A on this cut. Going for the computer. Clock is reading about 2 hours and 23 minutes. We'll say 2:24. 2:24, we should pick up Miche, and we'll also pick up a yaw check. 2:24, we have 056 on the other setting. Moon should be coming into view, and it should be, oh, what a beautiful yaw check this is. And it's approximately 10 degrees left of path, and to make that about 12 degrees left of path, just on the edge of the window. That should give us 0 yaw. I cannot see anything through the periscope that would help me. This edge is too... It is too cloudy. I'm cutting out on box. 1, 2, 1, 2. Box is now coming in very well.
Sigma 7, this is Miche, Capcom. How do you read, over?
Miche, this is Sigma 7. Read you loud and clear. How me?
Sure, you're loud and clear. Also, Wally, how about standard report?
Okay, Gene. I'll give you the suit thing first so everybody is off the hook. We have a dome on the suit of 7.2. That is dome temperature. I have a suit inlet of 6.6 on the suit. And the suit setting is 8. And I am very happy with the suit circuit at this time. I'm very comfortable.
Roger. Kate advised they're very happy with the whole situation. Is this particular ECS system solved itself, and they seem to think you have a good handle on the whole situation here.
Roger, I lost it for a while when I went back to the 3 setting, but I didn't stay there very long. It definitely should be up around 7.5 to 8. At this point, I am on ASCS Auto Retro Attitude. I'm going to go to fly-by-wire shortly. I have been on gyros normal, and maneuver has been off. All systems are green. I tapped off about 2% of manual one time by hitting RSCS. It was double authority. It was my boo-boo. It was just one pitch-down motion.
Roger. Understand and stand by.
Okay. I would like to go ahead with my night yaw check on fly-by-wire low.
Roger. We'll stand by.
Okay. I'm using the moon, which is to the left of me, and it's a real good fix for it. I'm just going to go ahead and cover up the attitude indicator, and you can watch the yaw. I'm going to gyros free. Going to select fly-by-wire low at this time. I'm going to put the moon in the center of the window first, and holding roll and pitch, and then put the moon back where it belongs. The moon is approaching the center of the window at this point. Okay, I'm going to stop it there, and we'll put the roll control in to get that balanced out. Okay, at this point, I will get 0 roll. I've overshot the moon, and I'm picking up the planet Mercury, which is nice and bright, and that's a little bit farther to the right. And I'll take a check off and just see how many degrees we've got here in yaw. About 20, which is enough for a quantitative check. We'll bring her back now. And I have to go ahead with slight roll motions each time I do this. This is to track the horizon, naturally.
Roger. Understand.
Okay, we're coming to the right, as you may be able to see. And we're coming around very well. I still have to correct my rollout. Coming up on yaw attitude very shortly here. I'm quite satisfied with both day and night checks. I've been real pleased with it. I have to say that this has been a real treat to see these bears fall into place.
Roger. Everything checks out just as you say on indication, Wally.
Okay, I'm going to give you a mark on the moon now for yaw reference. I would say this is now 0 yaw. Mark. How's it?
Just 4 yaw on the ground. That's pretty.
-4. Okay, I'll check here, and that's about right. I could have come right a little bit more. Okay, that's about all I need for a night yaw check. And as far as I'm concerned, I'll go back and give the guys some more ASCS time. I don't see any reason to spend up too much fuel. I'll give you one of those things for your Sir John.
Sure, understand. There's a few lights on it. Can you see anything?
We seem to be getting reasonable body temperatures now, Wal.
Oh, very good, Warren. Hey, nice to hear from you, old man.
Are you seeing Grandpa?
Oh, great sport. Understand some suds are on the way back. I might as well look down and see if you fellows have got some lights on. I'm going to kill the blood pressure.
Sherman just runs out of fuel. He doesn't get bogged in the sand.
I still have black skid marks on my swim fins from your trip into the bush. Okay, as you can see, I've yawed right again. I need to come, correction, yawed left. I need to come right. The moon is right on the horizon. I'll put her right in again just to show you how easy it is to acquire. I seem to be holding up on my fuel minimum, so I'll go ahead and play with it a little bit here. Okay, we're just about on in yaw. I'm still off in roll. I'll slap her in and we'll have her made. Here comes roll to straighten her up. Coming up on roll. Okay, I'm quitting right there. That's about as good as I'll ever give you. A little off and roll here. There we go. That's what I would give you. Okay, I'm going to go back to gyros normal and let them come back on the line, and I'm going to set up now. I've uncovered the instruments for chimpanzee configuration. Damn it, I'm sorry, it's auto mode.
Roger, understand.
I broke my promise.
We had you at a +5 roll when you uncovered.
Right, that's about right. Oh, I've got some lights down there. How about that?
Good, that's us.
That's a great deal. Sure, thank you all. I got a washer in here. I captured a washer and a piece of little metal, and this looks like sort of a conical washer, like a Voishan type or something. Better not be.
What time can you give us another blood pressure? That one cut off a little too soon.
Okay, let me get back into configuration here. I'm going to ASCS at this time, and she walked in without any high thrusters, I believe. Will you double check that? And for that, I'll give you a blood pressure.
Roger.
Got to check your Sanborn, I guess, for that one. Coming up on FPBMS. Gene, I'm real pleased with the suit temperature now. I've got a real steady 6.5, although the dome is reading just about 7.0 as a steady number.
Roger, 6.5 is dome 7.0.
Right. The cabin is just sitting here fat, dumb, and happy. I haven't had to do a thing to it. Have you been watching my 250 inverter? I've got
5.5 on the ground.
I've got 140 here, and the trend has been very slow building up. I don't think I'll change the cold plate settings. The 150 is holding about...
I recommend you go over to Woomera.
Roger. Woomera, Capcom, Sigma 7, over.
Sigma 7, Woomera, Capcom, loud and clear, over.
Roger. Nice to be back over Woomera.
Same here, and,
I'm a little bit...
Mode...
Okay.
Arrow position.
Roger, I am in ASCS Auto, in other words, in normal mode. Gyros are normal. Maneuver is off. All systems are green. I'm real happy with the suit circuit at this time.
Roger, we received your last report from Boucher, and is that auto retro?
That is auto retro. Would you give me a time hack at 3 minutes? Over. That's 2 hours, 3 minutes.
You want to hit your blood pressure stop?
Roger, can you read me?
Affirmative, we are reading you.
I need a mark on capsule elapsed time, your ground elapsed time. Give it to me at 30 seconds.
Roger. Five, 4, 3, 2, 1. Mark 023330.
Roger, I read 3-1. I'm 1 second fast. That's very good.
Your TM readout on your capsule elapsed time occasionally reads out 1 second fast and then comes out to be correct with our time. And then it gains a second again.
Welcome to the Quiver Club.
Right.
Okay, I think I gave you some good old blood for that one. Thanks for the swap.
Roger, that was the stop button. The stop button, we're still getting it.
Okay, I'll stop her.
Raj.
I was trying to give you the full bit.
Good, thanks.
Matt, you were so nice asking for it, I had to give it to you.
Oh, we meant the stop button.
Oh, for God's sakes, I gave you a whole new one.
It never quit.
I see.
Looks good now.
Good show. Okay, I feel happy about the fuel condition. I'm reading 95 auto, 90 manual. What are you reading?
Reading
98 auto and manual 94.
Well, how about that?
Full.
Spacecraft Commander, this is Warmer Systems. Did you have any high-pressure thruster action during your last pass over Warmer and Boucher?
I don't think so, because I was just cruising over you that time in fly-by-wire low and ASCS. I had one...
Decom jumped down here and indicated high thrust.
Right.
That was probably erroneous.
I'm quite sure it was, because I would have noted it rather rapidly. I made one large thrust application in the flight so far, where I was going back from manual proportional to fly-by-wire, and I forgot to move the rate command switch to auto. And I had one pitch function, and you really know it. So if I had a high thruster, I'm sure I would have known it.
Roger.
Very good. Thanks for looking out for me.
Yep. Everything looks green down here.
Oh, it's great up here.
Standing by.
Righto. I'm seeing a lot of your lightning now.
Yeah, we got a bunch.
I'll bet you have. Sorry I couldn't see your flare. I thought I saw it, but it was just lightning all the time.
Maybe next time.
Okay. I'll see, it looks like Africa looks pretty good down there. We'll give them a whack at it. Don't give up, though. I think the flare will help us someday.
We'll let Gordo take a look at it.
Right. I'm going to do a little stargazing now.
Homer has T.
Roger, Wilmer.
Sigma 7, Wilmer.
Go ahead, Wilmer. Now there's the old Corona Australis, shows in beautifully. And we've got Nunki, we've got Caos Australis, and Nunki is right on the flight path where it belongs. I'm reading 0 yaw, 5 degrees left roll, in retro attitude. I sure would like to know why it's so complicated. And up above those boys, I should pick up another brightie. Okay, that must be it. Has to be Altair. Yeah. Very good. One actually gets the feeling that you aren't really going over Australia on these flights. Okay, now let's see, we finished yaw checks for those boys. Coming up on Canton, they're getting more ASCS than they reckoned for this time. I tried that HF at 3 plus 20, everything else is in order. Take another look at that dome there over there. Your temperature is 6.4, and I'm really happy. PR minus 10 back to normal. I've done that earlier. Okay, we got suit pressure. go ahead and take a look at the inverters again here. 250 is 141. 150 is 107. Well enough alone. Standby is 7. About ambient. Negative, it's even a little. The cabin pressure is about 5.3, which is about it. Chute dome is 7.2. Cabin dome is 4.5, and cabin is holding. Chute temperature is about 6.4, and I like it. Oxygen is 6.0. Cabin O2 is 5.3. Make it complete electrical. All batteries are reading about 23.5 or higher. Ammeter is just about steady at 20 amps. Good one to check before we top down. ASCS is 115. Fans is about 1. Standby is 0. Okay, the cockpit is clean. It's obvious that damn antenna situation is no good. Just caught HS back in Bicone again.